Hello and welcome back again to our channel. And we are going to continue with mathematics and the calculus, specifically integration. And we're going to be looking at question and answers in this video because if you look at our 1 minute lecture videos that we do on integration or the different other topics and the mathematics, we've been focusing on lecture topics, but today we want to dedicate this video to an entire long video on questions and answers so that it can be a go get to video for you. We know you want to pass your exams and you want to practice as many problems as you can in more preparation towards your exams. So this is a very good video for such a course, or such a goal. So it will be without much wasting of your time. Let's zoom straight right in. So today we'll be looking at integration, and if you've come to realize, differentiation deals with a problem that we have when we have to estimate the slope or a gradient of a curve, anything that's non-linear, because we know that when we want to deal with linear stuff, we can be able to estimate the slope or the gradient. We can be able to estimate the slope or the gradient, which is y2 minus y1 over x2 minus x1. It's easy. But what if it is non-linear? When it is non-linear, then the rule, like maybe a curve like this, how do you be able to estimate the slope here? It's going to be difficult, but this slope here is going to be different from the slope there. But for the straight line, the slope between these two, sorry, let me take a different color. The slope between these two is the same as the slope between these two here. So if there's A and B and there's C and D, the slope here is the same as the slope there. But with a curve here and here will be different. The slope here will be different from the slope there. And that is where differentiation comes in. So helps us. Differentiation helps us deal with such a problem. Differentiation helps us to deal with such a problem. On the other hand, when we want to be able to estimate what we call areas and volume. Remember, if we say if we are asked to find the area of a rectangle, the area of a rectangle is the length times the breadth. But what if we're being asked to find the area under a curve? Area under a curve. It's going to be hard. We need to be able to have smaller rectangles to be able to estimate them by approximation, which is hard. And that's where integration comes in. So the role of differentiation and the role of integration is very critical. It's paramount to be able to address those kind of problems. So that's today we are going to focus on the integration part, where it allows us to be able to estimate and areas and volume. So our first question for today, imagine we have the integral of x to the power of 5 dx. X to the power of 5 dx. Now, this type of integral is known as the indefinite integral. Why? Because it doesn't have any lower limit. There's nothing here, and then there's nothing there. So there's no lower limit, there's no upper limit. So it is known as an indefinite integral. If it has some numbers over here and there, then it becomes a definite integral. I think we'll get there and we will see something like that. Now, so let's zoom straight right in. So imagine we have this indefinite integral, which is x to the power of 5 dx. We said the first thing we're going to do is to add 1 to the numerator, to the power, and then we divide that by the result at the power. So the result at the exponent is 5 plus 1. So we do the division, and we don't forget, we're going to introduce what is called the arbitrary constant, which is C. This is known as the arbitrary constant. The reason why we introduce a C as an arbitrary constant is because we are dealing with an indefinite integral. If it's a definite integral, we do not need it. We don't need it. But in this case, we do. So to continue, our answer is going to give us x to the power 6 divided by 6 plus C. Therefore, you have 1 over 6 x to the power 6 plus C as our final answer. Now, let's take another one. Imagine that we have a definite integral of 3x squared dx. What we're going to do is to add 1 to the power here and divide by the result, which is 2 plus 1. And then we add a c to it. So we're going to have 3x to the power 3 divided by 3 plus c, and we're going to have 3 over 3 x cubed. This 3 cancels out, plus c, and we end up getting x cubed plus c. We end up getting x cubed plus c, and that's our final answer. Now, let's take another problem. If you have the integral of 2x to the power 4 dx is going to be equal to 2x to the power 4 plus 1, and we divide by the result, just 4 plus 1, we end up getting 2x to the power 5 divided by 5. But don't forget, we need to add our c. We need to add our c. So we have 2 over 5, 2/5 of x to the power 5 plus c. And there you have it. And there you have it. Now, let's take another one. We are having an integral, a definite integral of 2 divided by x squared dx. We will first have to rewrite this. And to rewrite that, we end up getting integral of 2 to the 2 multiplied by x to the power negative 2 dx. And then we do the usual. The usual is to add 1 to the power and then divide by the result and then introduce our constant c. Now we're going to have 2 to the 2 multiplied by x to the power negative 1, all divided by negative 1 plus c. And then we have 2 over 1, 2 over negative 1 multiplied by x to the power negative 1 plus c. Can you see that? Now when we are going to continue here, we're going to get our 2 is equal to 2 over negative 1 multiplied by 1 over x to the power 1. Remember indices, if you have a to the power negative n, is the same as 1 all over a to the power n, making the exponent a positive. So we end up getting plus c here. This is going to give us 2 over negative x plus c, which is the same as negative 2 over x plus c. All right, I hope that clarifies some of the problem. Now imagine that we also have the integral, the definite integral of square root of x dx is the same as integral of x to the power half dx, and then we're going to add 1 to it. So we're going to half plus 1, and we divide by the half plus 1, introduce the c, is going to be equal to x to the power 3 over 2. If you do half, don't forget your fractions. If you work this one somewhere, it's the same as half plus 1 over 1. This multiplies this, you get 1. This multiplies this, you get 2. Divided by this multiplies this, you get 2. So it's going to be 3 over 2. So the top here is going to be 3 over 2. And then the bottom part, which is the denominator, is going to be 3 over 2 plus c. So we're going to have x to the power 3 over 2 divided by 3 over 2 plus c. And let's say we are going to continue somewhere here. We're going to continue somewhere there. We're going to continue somewhere there. We're going to have x to the is equal to x to the power 3 over 2 multiplied by 2 over 3. It changes. Remember your fractions. Plus c, it changes, right? It's equal to 2x to the power 3 over 2 over 3 plus c, and that becomes our final answer. Now let's take a look at a different example. Imagine you have an integral, still on a definite integral of 3x plus 2x squared minus 5 all dx. The moment we see something like this, remember this whole thing here is called the integrand. The integrand. So this integrand here, we're going to break it down into, we're going to break them down one by one. So we're going to have integral of 3x dx plus integral of 2x squared dx minus integral of 5 dx, like this. All right. Now, this is going to give us integral of 3x dx. I'm rewriting them again because of what I'm going to do here. So the 5 is going to be the same as 5 multiplied by x to the power 0, because we know that any number raised to the power 0 is 1. 1 times 5 is 5. All right. And then we bring our dx here. Now, we're going to add 1 to the top. So it's going to be 3x 1 here. There's already an invisible 1 here. Add 1 to it, and then we divide by the 1 plus 1. Plus, it is going to be 2x squared plus the 1 divided by 2 plus 1 minus 5x0 plus 1 divided by 0 plus 1. Don't forget the c if it's an indefinite integral. So we end up getting, I'm changing color. We end up getting 3x squared over 2 plus 2x cubed over 3 minus 5x over 1 plus c. And then we end up getting 3 over 2 x squared plus 2 over 3x cubed minus 5x plus c. And that gives us our final answer. That gives us our final answer. Now, let's take a look at another one. Another one here. Imagine we have an integral with the integrand being x cubed plus 1 over x squared plus square root of x all into dx. What you're going to end up getting is, we're going to rewrite this, is going to be equal to the integral of x cubed plus x to the power negative 2 plus x to the power half all dx. And then we said that we integrate them individually. So it's going to be x cubed dx plus x to the power negative 2 dx plus x to the power half dx, in that order. Now, when we want to do that, it's going to be x3 plus 1 at the top divided by that plus x to the power negative 2 plus 1 divided by negative 2 plus 1 plus x to the power half plus 1, you divide by the same thing, half plus 1, like that. And then we don't forget our c, our arbitrary constant. Now we end up getting x to the power 4 over 4 plus x to the power negative 1 over negative 1 plus x to the power 3 over 2 divided by 3 over 2 plus the arbitrary constant. Now, if you don't get anything, you can pause the video at this point, and then once you pause the video, you can work it separately somewhere, come and continue with the video. If you haven't yet subscribed to our channel, please do us a favor by subscribing. So by subscribing and turn on all your notification bells so that when we post any video, you'll be notified. Now, to continue, we're gonna have 1 over 4 x to the power 4. This is going to be negative. This is negative x to the power negative 1 plus x3 over 2 divided by 2 over 3 plus c. And when we continue here, we're going to have it's equal to 1 over 4x to the power 4 minus 1 over x. This is going to give us plus x3 over 2 multiplied by, this is supposed to be, this side is supposed to be 3 over divided by 3 over 2 plus c. So it's going to change to be 2 over 3 plus c. And then we have 1 over 4 x4 minus 1 over x plus 2 over 3x to the power 3 over 2 plus c. And that gives us our final answer. It gives us our final answer. Now let's take a look at a couple of different problems still on indefinite integrals. Now imagine that we are given an integral with the integrand t cubed plus 3t squared minus 1 divided by t squared all dt. Now, we always say that let's simplify. So to simplify, we're going to get t cubed divided by t squared plus 3t squared over t squared minus 1 over t squared all dt. And then you're going to have integral of t, 3 minus 2 plus, you're going to get 3 t squared minus 2 minus 1 over t squared, like this, all dt. Now, this is going to be integral of t to the power 1 plus 3t to the power 0 minus t to the power negative 2, if you want to change it, all dt. Now, remember we said that when we get here, we're going to integrate each of them one at a time. So this is going to be t to the power 1 dt plus 3t to the power 0 dt minus t to the power negative 2 dt. Now, when we continue here, we are going to get t to the power 1 plus 1. We divide by 1 plus 1. Plus 3 multiplied by t to the power 0 plus 1. We divide by 0 plus 1. Minus t to the power negative 2 plus 1. We divide by negative 2 plus 1. And don't forget the arbitrary constant, because we are dealing with indefinite integral. We're dealing with indefinite integral. So here we're having the numerator to be t squared over 2 plus 3t to the power 1 over 1 minus t to the power negative 1 over negative 1 plus the arbitrary constant. Now this is simply half of t squared plus 3t to the power 1. And then don't forget this negative and this negative become positive, and we get t to the power negative 1 plus c. And we have half t squared plus 3t plus 1 over t plus c, in that order. In that order. In that order. I hope everything is clear. If you're not able to get it fully at first hand, I will advise you pause the video, go back a little bit, and try to see the steps that that is not clear to you, and it will come up. Or if you are maybe tired, it will be good to take a little break, take a break, drink some water, go and walk around, maybe go back to some movie, or go to the gym, do something, and then you come back well refreshed, and you can be able to continue. And I'm sure the things that are difficult will become clearer. There'll be clarity. There'll be clarity for you. Now, the next set of questions or problems that we'll be looking at will primarily be more related to what is known as the definite integral. The definite integral. So let's take the first one, and let's see how it's going to speak to us. So the first one, imagine we have the integral of this integrand 3x squared plus 2x plus 4 all dx, for example, and the lower limit there is 1 and the upper limit here is 3. This is what makes this integration or integral a definite integral, because there is a lower limit of 1 and an upper limit of 3. So we're going to still apply the same rules. It doesn't change much. What we're going to do is that we're going to integrate them individually. We're going to integrate them one by one. So it's going to be integral of the 3x squared dx, but this time lower limit of 1, upper limit of 3, plus integral of the 2x dx. This time lower limit of 1, upper limit of 3. The next one is integral of 4 dx, lower limit of 1, upper limit of 3. Now, when we do that, we're now going to apply the normal differential integration that we know, which is going to be 3x to the power 2 plus 1. We divide by the 2 plus 1. Now we put in a certain box. We put a lower limit to 1 here, upper limit of 3 there, plus we're going to integrate 2x, which is going to be 2x 1 plus 1 divided by 1 plus 1. We also put that in a box, which is 1 to the 3, plus we integrate 4, which is going to be 4x to the power 0 plus 1 divided by 0 plus 1. We also put that in a box, lower limit of 1, upper limit of 3. Now, what we're going to do here next is going to be to put in 3 and subtract from 1. So we're going to have 3 into 3 and then 2 plus 1, like this, divided by the 2 plus 1. All right, minus putting in 1. So we're going to have 3 into 1, 2 plus 1, all over 2 plus 1, like that. Okay, so this whole thing that we've done here is just for this side. We're going to repeat it. We're going to do the second part. Which is the plus here. So it's going to be plus, same thing, open a parentheses, and it's going to be 2 into 3. Put the 3, wherever we find x, we put 3 into 1 plus 1, divided by 1 plus 1. We close it, minus 2 into 1. We put in 1 here, into 1 plus 1, divided by 1 plus 1. And then we close that. We close that parentheses, and we're done with the second part. We're done with this whole thing here, represents this. So the next one is the last part, which is going to be And into bracket is going to be 4 into 3, 0 plus 1, all over 0 plus 1, minus 4 into 1, 0 plus 1, all over 0 plus 1, in that order. Now, this is going to give us, this here is 3 to the power 3. So it's going to be 3 multiplied by 3 to the power 3 over 3, minus, this is going to give us, this is basically 1. It's going to be 3 into 1 to the power 3 over 3, in that order, plus this is going to be 2 into 3 squared over 2, minus 2 into 1 squared over 2, plus you're going to get 4 into 3 to the power 1 over 1, minus 4 into 1 to the power 1 over 1, in that order. Now let's try and see if we can continue up here. This is going to cancel this. So basically you have 3 cube is going to be equal to 3 cube. This also canceling this. You have minus 1 cube. This is going to cancel this. You're going to get plus 3 squared. This also canceling. We're going to get minus 1 squared. And then you're going to have plus 4 into 3 minus 4 into 1. Basically, this is going to give us 27, because this is the same as 3 times 3 times 3. Just 9 times 3 is 27. Minus 1, because 1 cube is 1 times 1 times 1, which is 1. Plus 3 squared, which is 9. 3 times 3 is 9. Minus another 1. Plus 12 minus 4. So we end up getting 20. We're now getting 26 plus 9 minus 1 plus this 2 gives us plus 8. So we're going to get 35 minus 1 plus 8, which is going to be 34 plus 8, which is 42. 42 being our final answer. Would be our final answer. Now let's take a look. Let's take a look at something quick here. Let's take a look at another type of definite integral. Imagine you have this definite integral of the integrand being x plus 1 multiplied by another function x squared minus 2x plus 2, all divided by x squared, in that order, with the dx. Lower limit here is 1, upper limit is 2. Lower limit of 1, upper limit of 2. So what do? We first have to simplify what's on the inside. We simplify what is on the inside. What do? We can first expand. We can let this multiply this. We're going to get x cubed. X is going to multiply this. We're going to get minus 2x squared. This x is going to multiply this. Is going to be plus 2x. This one is multiplying this. You're going to get plus x squared. That one is going to multiply this. It's going to be negative 2x. It's going to multiply the 2 plus 2. And then we divide everything by x squared. And how about the x there? Now we're going to have x cubed. I think this and this are the same. And this will go off. If I change the color, you can see that this one here. Sorry. Let me take that again. So let me wipe that neatly. I need to take my time. Okay, so we're saying that, if this plus 2x here will take on this negative 2x and it's gone. Say bye to each other. Now we're going to have our x cubed minus 2x squared plus x squared plus 2 all over x squared, and then we have our dx here. So we have an integral of x cubed minus x squared plus 2, right? Plus 2. And then we are going to divide that by x squared dx. Now, we divide each of them by x squared. We're going to get this minus x squared over x squared plus 2 over x squared, all dx. And then we end up getting integral of x to the power 3 minus 2 minus x to the power 2 minus 2 plus 2 to the power x minus 2, all dx. And then we have x to the power 1 minus x to the power 0 plus 2 to the power x minus 2, all dx. And then we take them individually, so we're going to get x1 dx minus x0 dx plus 2x to the power negative 2 dx, which is going to give us integrating it. Now, don't forget, we need to be putting back our lower limit 1, 2, 1, 2, 1, and 2, 1 and 2. This is going to be 1 and 2, 1 and 2, 1 and 2. So we're going to put that in. We're going to have x to the power. When we integrate, we're going to get x to the power 1 plus 1. When we're integrating, we divide by 1 plus 1. And then we put it in a box, which is 1 to 2. Then this negative would come here. This negative here will come here. And then we integrate again. It's going to be x to the power 0 plus 1 divided by 0 plus 1. And put our box in there. Plus 2 multiplied by x to the power negative 2 plus 1 divided by negative 2 plus 1. Put our box at 1 and 2. So we end up getting x squared over 2, 1 to 2, minus x to the power 1 over 1, 1 to 2. Then we are going to get minus, because, or plus, let's say 2x to the power negative 1 over negative 1, 1 and 2. We put in 2, we get 4. We put in the 2 here, this 2 inside the x, we get 4 over 2 minus, we put in the 1, we get minus 1 over 2. Can you see that? Minus, we put in this 2, it's going to be 2 over 1 minus, there's a minus first, that's what I put, that's why I put the parentheses in there. So we put in a 2, it's going to be 2 over 1 minus, putting in another 1 right there. Minus putting another 1 right there. So we put in a 1, and we get 1 over 1 like this, plus, bring the parentheses, 2 goes in there, it's going to be 2 into 2 to the power negative 1 over negative 1, minus, put in the 1, you're going to get 2 into negative 1 to the power negative 1 over negative 1, in that order. I think it's getting a bit messy. It's getting a bit messy. So, I mean, this gives us 3 over 2. And then this one gives us, this one here is supposed to give us 1 over 1, which becomes negative 1 over 1. And then here we are getting 2 to the power negative 1 is basically 1 over 2. 1 over 2. It's basically 1 over 2. And this 2 cancel that out. This 1 over 2, this 2 cancel that out to give us 1. 1 over 2 is going to give us 1 at the top. So we end up getting plus 1 over negative 1 at the bottom. This one also, this one here is also the same as 1 1 over negative 1. This one here, 1 over negative 1 multiplied by the 2, we're going to get 2 over negative 1, then divided by negative 1 again, divided by negative 1. Now that gives us negative 2 over 1 multiplied by 1 over negative 1, and then we end up getting 2. So we get minus 2 over 1 here. Yeah, minus 2 over 1 here. Now, all this here is over 1. If you can see that, all this over 1 here. This negative can actually be at the top. So that we're going to get negative 1. We're going to get negative 1, negative 1, negative 2. So it's going to be negative 4 over 1. So we have 3 over 2, negative 4 over 1, which gives us 3 minus 8 over 2, which is going to give us negative 5 over 2. Was giving us negative 5. It's giving us negative 5 over 2. Negative 5 over 2. All right? Giving us negative 5 over 2. Negative 5 over 2. So you can work it and take your time and see where this leads you. All right? Let's continue with another question here. Continue another question here. And here we're gonna have a question, and the question says that I have the integral of x squared minus 2 multiplying 2x minus 1 all dx, and then we have our lower limit being negative 2, upper limit is also 2, like that. So the first thing is, I think we need to expand first, and to expand we have a negative 2 here and 2 here. This will multiply this, and we're going to get 2x to the power 3. The same x squared is going to multiply. We have minus x squared. This multiplies this, you get negative 4x. And this same thing multiplies here, you get plus 2. And then all the x. You're going to have integral of negative 2 and 2. And we can take them one at a time, like this. Dx minus negative 2 to the power 2. We have x squared dx minus integral of 4x negative 2 to 2 dx. And then we're going to have 2 dx negative 2 and 2. Now we're going to integrate, and when we integrate, we're going to get 2x to the power 4 over 4. Put in the box negative 2 and 2 minus, put a box there, x cubed over 3 negative 2 and 2 minus a box 4x squared over 2 negative 2 and 2 plus 2x over 1 negative 2 and 2 in that order. Now when we do this, when we put in our 2, we're going to get 2 into 2, 4 over 4, like this, minus, we put negative 2. So we're going to have 2 into negative 2 and 4 all over 4, like that. Then you're going to have minus again. And this time we're going to put 2. We're going to get 2 cubed over 3. And then we are going to also have a minus. And then the minus, we're also going to have a negative 2 to the power 3 over 3 in that order. And then we're going to have minus, big bracket. You're going to have 2 going to 4 into 2 squared over 2 minus 4 into negative 2 squared all over 2 in that order, plus we're going to get 2 into 2 over 1 minus 2 into negative 2 over 1 in that order, like that. Now, if we want to continue at the top here, this whole thing here, this 2 is going to cancel this one. So you're going to have 2 to the power 4 over 2. And then if you look here, negative 2 to the power 4 is going to be a positive number. But this 2 is also going to cancel this. So we're still going to have our minus, and then we're going to have negative 2 to the power 4 over 2. Now here, we're going to have minus. It's going to affect this whole thing. So we're going to have 2 cubed over 3. And this negative is going to affect this negative to be positive. It's going to be positive. But we're still going to have negative 2 to the power 3 over 3. Now here, this negative is affecting that. It's going to be negative, but you see this 2 is going to cancel this. You're going to get negative 2 into 2 to the power 3. This is also going to cancel that to be 2, but the negative and negative here is positive. It's going to be plus. And once it becomes plus, we're going to have 2. This cancels this to be 2. So we have 2 into negative 2 squared, like that. And then we are still having our plus. Now, the top part here is going to be 4 over 1. And then we're still going to have a minus. And then this whole thing is minus 4, right? So it's going to be plus 4 over 1, like that. Now, as you can see here, this and this is going to be 2 to the power 3, right? And then we're going to have minus. This is supposed to be 16. Negative 2 times negative 2 times negative 2 times negative 2. So this is 4 times 4, which is 16. It's going to be minus 16 over 2. And then this is going to be minus 8 over 3. This is going to give us minus 8 over 3, this one. And then this one here is going to give us minus, this is 2 to the power 3 is 8 times 2, which is going to be negative 16. Which is going to be negative 16. And this is going to give us plus, this 4 times 2 is going to be plus 8. And then this is going to give us plus 8 over 2, plus 8 over 2. So we end up getting 8 minus 8 minus 16 over 3 minus 16. And then we have plus 8 plus 4. Now, if we can see here, This goes away, and then we end up getting negative 16 over 3 minus 16 plus 12. Can you see that? We end up getting negative 16 over 3 minus 4, minus 4 over 1. And we can be able to solve that. LCM is going to be 3, or this multiplies to get negative 16. And then this multiplies to get negative 12 divided by 3. And we end up getting negative 28, negative 28, negative 28 over negative 28 over 3, negative 28 over 3, negative 28 over 3. So you can take a look at that again. We started off by doing x squared minus 2 and 2x minus 1. We're multiplying them together. We expand, and when we expand, we had our 2x cubed minus x squared minus 4x plus 2 dx, and we integrated them together. When we integrated this, we're supposed to get 2x4 over 2, 2x4 over 2. So that's going to be 2x4 over 2 is going to be x to the power 4, x to the power 4. And with x to the power 4, we're going to put in our 2, right? Yes, so we said 2x to the power 4 over 4. So we did that. With the same way here, it's going to be negative x cubed over 3 in that order, right? So when we work it out, you're going to be able to get your final answer as it is. Now, we want to continue. Next time when we meet again, we're going to be looking at the different types of integration. We are going to look at integration by substitution and different types of methods of integration, which becomes messy. All right, I'll come to you another time. Take care and bye.